So the learning objective for this particular session, as you can see, first of all, let us understand what is IMO, because all of us seafarers are governed by IMO. IMO is nothing but the maritime branch, or you can call it maritime wing of United Nations. So the IMO itself came into being in the year 1948. So IMO was adopted in the year 1948 at United Nations, and effectively it came into force, you can say, in 1959. So 1948, in fact, if you can recollect, in the year 2018, say 2 years back, we had a 70th anniversary of IMO, and all over the world, IMO conducted seminars, and we had one in Chennai in Seafarers Club, and many IMO related topics were presented there. So it's almost 70 years from 1948. Now it is, I should say, 2 years added, 72 years. As I have said earlier in my last session, the objective of IMO, you can put it in a nutshell. So what does it say? Cleaner. It's basically it talks about safety, safer and secured shipping, and energy efficient shipping. Safer, secured, energy efficient shipping on cleaner ocean. So this covers all the what they call 4 pillars of IMO. So IMO has got so many committees. Very main committees are about, say, 5 committees, starting with Maritime Safety Committee and Marine Environmental Protection Committee. Apart from that, other committees for administrative reasons. But anywhere in the world, any shipping disaster or anything related to safety, maybe fire engulfing a ship or a ship sinking or loss of life, any such thing, your MSC looks at it critically, and then it has a brainstorming session, and it either brings out new regulations or fine-tunes the existing regulation so that in future, any such recurrence of such incidents is not happening. So likewise, if you see MEPC, Marine Environmental Protection Committee, yes, anywhere, any major pollution incidents, your MEPC critically is looking at it. And then accordingly, changes are made, what we call amendments. So if in IMO terminology, if you see, initially we say adoption, then we move on to ratification. So ratification. So like, I'll give an example. You take MARPOL. MARPOL, what do we say always? We say MARPOL 73, 78. Now what does it signify? Suppose when it says 73, it is 1973. In 1973, MARPOL, International Convention for the Prevention of Pollution of Ships, was adopted. So when we say 73, 73 is year of adoption. Whereas 78, in 78, very often people misunderstand and they keep telling me 78 is the ratification date. No. Whereas if you see different annexes of MARPOL, different dates of ratification. Like for example, Annex 1 got ratified in the year 1983, to be precise, 2nd October 1983. Likewise, Annex 2 in 1987. So it keeps going like this. In fact, Annex 6 in 2005. So it keeps, so different dates for ratification. Whereas then what does it say? 1978, 73, 78, what does it signify? 73 is year of adoption. 78, they adopted a protocol. We need to know that because MARPOL has got 2 protocols. These protocols are very important. Protocol is basically after the convention has been adopted, before ratification, if any changes or additions are made to the original convention, which has not yet been ratified, please underline that, not yet been ratified. Once it is ratified, any changes if we make, then we use a term what we call amendment. This is not amendment. This is before ratification protocol. So 2 protocols of MARPOL. The first protocol talks about reporting. Anywhere, any oil spill or any noxious liquid substances, any of the spills, you need to report. Reporting is the first action you need to take. So as you can see in IMO, every convention has got significance, and adoption, ratification, amendment. So that's how it goes. Like what are the 4 pillars of IMO? What I have mentioned earlier. First one is SOLAS. After Titanic incident, SOLAS came. Next one is Tory Canyon. Tory Canyon incident took place in 1967. So in 1973, they brought out Marpol Convention to have a control on marine pollution. And the third one, STCW. All of us, we know that. Standards for training, certification, and watchkeeping of seafarers. One of the very important convention. In fact, that decides the competency. That decides the proficiency, understanding, all those things. So STCW is you can say the third pillar of IMO. Then what is the fourth pillar? Fourth pillar happens to be, the seafarers are competent enough, all right. But the seafarers need to be looked after when they work on board the ship. That means to provide decent living and working conditions for seafarers, they brought out a convention, what they call a Maritime Labor Convention, to look after the welfare of the seafarers. So these are the four pillars of IMO. And in fact, the last one, Maritime Labor Convention, is basically, it is from ILO, International Labour Organization. Okay. Now we will move on. Now the overview of IMO, we have an idea. MEPC, what is MEPC, what is MSC, what are of course, the only four conventions, the main conventions I have mentioned. Yes, you have conventions like load line, we have a convention, tonnage, we have a convention, and so many other conventions. For pollution regulations, we have call rate. So many conventions, like for example, ship recycling convention is waiting to get ratified. So there are a number of conventions there. So the future IMO legislation, if you are looking at, as I have said in this presentation, we will look at some of the requirements of IMO, which has already come in the last 2-3 years. And in the next 2 years, what are the new things are going to come, which has been already adopted and waiting to get ratified. So like Polar Code is, we have already come, say in 2017. We will briefly look at what is Polar Code. And I mentioned earlier also, Polar Code has become the 14th chapter of SOLAS. And Marpol is also included. So, and next is IGF Code. We need to have as of now, we have a code for international code for what we call gas fueled ships. So, IGF Code also a little bit elaborate, we will look at it. And of course, LNG fueled ship, yes, that is related, that's connected to your IGF Code. Now the ship owners are more and more, looking at alternate fuel instead of fuel oil. Why not we use liquefied natural gas? So why do they do? What are the reasons? What type of ship? Like if you need to do LNG bunkering, all of us are very familiar with doing diesel oil or fuel oil bunkering. But if it is going to be LNG bunkering, what are the issues? What are the problems we will face? What sort of safety precautions the ship staff need to take? All those things are covered, and briefly I will touch. Then the next one is Ballast Water Convention, which has already been ratified. We all know in 2017, Ballast Water Convention, which was pending from 2004 onwards. For a long time it was pending. And in the meantime, many coastal administrations like US as well as in Australia, like your AMSA regulations or your European Union, many countries, they have come out their own, ballast water. And eventually, Ballast Water Convention by IMO also got ratified. So we will briefly look at it. And of course, the last one is a very, very interesting topic, and seafarers are a little bit worried about it, what we call autonomous ships. So this is also an initiative of IMO. I just have 2 slides on autonomous ships. Right at the end of the session, we will briefly look at the autonomous ships. And many of us, we still feel autonomous ships is not possible, and semi-autonomous is possible. And eventually what IMO is looking at, or the industry is looking at, running a ship without anybody on board. So anyhow, let's look at it. Okay, now this, I'll not dwell much upon this, because in my last Annex 6 update, I have already covered it. So a new chapter has been added. This has been done in the last 3 years, as you can see. This basically global warming and CO2 emission level. But then more than this one I would like to touch upon. So the previous slide, what you saw, that was a regulation given, a chapter added in Marpol Annex 6. But then how do we achieve this? When you see greenhouse gas emission, greenhouse gas like carbon dioxide is a greenhouse gas. Now look at hydrocarbons. That's also a greenhouse gas. So how the shipping industry? What are all the avenues available for us to have a better in the sense optimized or reduced CO2 emission? So the ship size increase. Instead of just imagine, instead of 2-3 ships of having about 40,000 tons carrying cargo, if you just have one ship doing about 120,000 tons, a ship going from A to B. If you just look at the CO2 emission, 3 ships versus one ship of higher capacity, if you will always look at the fuel consumption and eventually which projects the CO2 emission comes down when you go in for a size. So that's why it is written there, increase in ship size. Engine power ratio. See, all the time, the engine makers are looking at optimizing the SFOC. How much was the SFOC for engines earlier, specific fuel oil consumption. So if you can optimize, if you can minimize that, that is going to be a plus point for us. So that eventually reduces the fuel on one hand, but more than that, that reduces the CO2 emission. So engine power ratio, the engine makers are looking at. Now, as of now, look at the camshaftless engines like your ME engine or your Artiflex engines. They are talking about attaining a SFOC of about, say, 118, 120 grams per kilowatt hour. So if they can effectively achieve that type of SFOC, it is definitely a sort of a reduction in CO2 we just looked at. And what is the next point? It talks about light ship weight. So how can you reduce the light ship weight? Because basically, if you see the LDT, in fact, when the ships are scrapped, more the auction, ship auction, the buyers are looking at the LDT. LDT is effectively how much steel is available when the ship is beached, how much they are going to get benefit. More steel they get, it is better for them. So light ship weight, if you reduce, eventually what we are looking at, so that is going to have an effect on the reduced resistance. So when the vessel is underway, one thing is what we call wetted surface area. In naval architecture, we have studied. So when the vessel is floating, you look at the wetted surface area. If the surface area is reduced, that means when the vessel moves or when it moves, then resistance is reduced. So in the design, naval architects are looking at how to reduce the wetted surface area. So now, apart from that, the light ship weight, it also depends upon what type of steel we use. Are we using Lloyd's grade B steel? Because we have different grades of steel, A, B, C, and also we have high tensile steel. As all of you are aware, in fact, the tankers, oil tankers, when they switched over from single hull to double hull design, the ship owners were looking at using more of high tensile steel. So how does it help us? So your HT steel, for the same plate thickness, if you are looking at the tensile strength, for a conventional Lloyd's grade B steel, if it is going to be somewhere around 400 to 500 tons per Newton meter, but whereas for this type of HT steel, you will find 550 to 600 Newton per millimeter. So there is what is the advantage? That means the lesser plate thickness can be used. So when you look at it, then eventually it will have an effect on the LDT. So lighter ship means what? That means the fuel consumption eventually leading to CO2 emission reduction will occur. Now, apart from that, now look at the next point, what we call air bubble. Now, this air bubble thing, if you see here, I am putting it innovative solutions. Air bubble, or the air bubble is what, having a blower and then sending air bubbles under the hull, because the hull is in contact with the water. So in between the water and the bottom of the hull, if there is a shallow or the profile of the ship's bottom is made to such an extent, if air bubbles are present there, probably it will have a friction reduction. So that's a concept there, and of course they are already trying out for ships. But I understand, I have come across some chief engineers telling me that their ships had it, but effectively it is not for every ship. It has not yet come. I would say probably it is still at laboratory or study stage. It hasn't. They haven't brought it for all the ships. Because what happens, they say that it is difficult to keep the bubbles there under the hull profile. Suppose as and when the bubbles keep escaping or leaking out, then you need to keep running a blower for a longer time to keep supplying the bubbles. Probably the blower consumption, that is going to increase in power. So you need to look at it. Then the next one is propeller efficiency. As you can see, propeller efficiency, even earlier we looked at ducted propellers. Always the point is the wake that is produced by the rotating propeller always creates some sort of an axis, thrust. Now this thrust moves the tail shaft or the shafting system right up to your thrust block, where it comes on the thrust block foundation and to the tank top and to the hull, so the ship moves. But what happens now, the efficiency when the propeller is rotating, apart from the axial flow of wake, there is radial flow of water which is being wasted. We are using it. So why not we convert that again into the axial thrust? So we have ducted propeller probably. See, there is a duct around the propeller blade, number of the propeller blades, or the propeller tape bending it slightly, or to have contra-rotating propeller. There are many things that are looked at to have an effective ship design. Of course, speed reduction, as all of you are going in economical speed or reducing the speed, always reduces the CO2 emission. So again, this one also last class I just casually touched it. Wind, solar power, so renewable power source. So that will bring down your CO2 emission. Of course, low carbon fuel, LNG bunkering, we will have a look at it after some slides. And of course, energy saving devices like waste heat recovery, shaft generator, and this type of things helps. Okay, now in IMO in 1974, they have brought out this. So this is basically for bulk carriers and oil tankers. And as you can see, from 1st July 2020, it is a requirement. So what it is, let us understand. Goal-based standard means what? IMO has got a goal. What is the goal? That means the ship has to have a life. Let us say 25 years. If you just plan, if your goal is to operate the ship for 25 years, during this 25 years, if the vessel is maintained well and operated well, the vessel shouldn't have any issues, should fulfill its 25 years life without any issues, whether it is intact as well as in damage stability conditions. So that's what is the goal set by IMO. And basically, more than the direct ship owners or ship staff, you can just say this is a guidelines to the IACS. As you can see, the last point, the IACS, International Association of Classification Societies, they have common structural rules for tankers and bulk carriers. So have been audited by IMO and found to comply with the GBS standard. Now this is what, now earlier we always used to see IMO at the level of only making regulations, but now slowly IMO, apart from making guidelines, making regulation, making convention, slowly moving in just to look at how the guidelines are being implemented by the flag state. If you just look at the 13th chapter of SOLAS, or as well as in MARPOL, many annexes, they talk about verification of compliance, which in my last class I have already touched. So IMO would like to do that. IMO would like to form an audit committee and to check. So likewise here again, in goal-based standards, you can just see this is what IMO wants to do. So the goal-based standards is basically 5-tier system. So if you see tier 1, tier 2, and tier 3. What is tier 1? Tier 1, setting the goal. What is the goal setting? I already told you. Keep the ship to run for 25 years. That is the goal. As long as the vessel is well managed and well run with proper maintenance carried out, the vessel should stay for 25 years without any issues. So, so how to achieve this goal? Then you look at tier 2. Now this tier 2 is called functional requirement. Now functional requirement, we look at all these things. Now these are all the tier 2 requirements. I'm just briefly touching it. I don't want to go too much deep here. So what is the design life? As I have said, keep a design life of 25 years for a ship. And environmental condition, as all of you are aware, looking at the load line convention, so which is a very, very severe environment. Definitely we said North Atlantic. And even in your load line, plimsoll marking, you must have seen summer load line and winter load line and winter North Atlantic. Now, that is where the environment is going to be highly difficult to manage. So, the environment, that means the ship needs to be designed to the North Atlantic environment. Now, apart from that, look at the strength of the ship. Suitable safety margin is given, so proper scantlings. So, the scantlings will provide, the required strength for the ships. And fatigue life, see, North Atlantic, 25 years fatigue life. Yes, the vessel is underway in different environments. Panting is taking place, pounding is taking place. So many ship is, as all of us are aware, that ship is having 6 freedoms of motion: rolling, pitching, surging. So many yawing. There are about, say, 6 different freedom of motion, we say. So all the time the ship is, panting, pounding. So all these things will cause fatigue. So fatigue life. So accordingly, the ship has to be built. Accordingly, the materials of construction, starting from the steel selection, needs to be done. As all of us are aware already, the classification societies give the guidelines under IAX, but IMO just wants to audit what has been made by IAX also. So residual strength, it needs to be sufficient, as you can see. Now, protection against corrosion, yes, coating design. What sort of coating, what sort of paints we are going to use? The paint, apart from the paint quality, how the surface preparation has to be done. Suppose if the paint is qualitative and if the surface is not properly prepared, then we are going to have issues. So surface preparation is again equally important. Apart from that, what should be the thickness of the paint? We say primer coat when you give, what should be the DFT? Should it be 125 microns, or it should be more, or it should be less? How many coats we need to give? How much should be the finishing coat? And especially where it is in contact with seawater all the time, I'm talking about hull outer surface, underwater areas. So now, apart from the top coat, do we need to give some anti-fouling, self-polishing coat? So these are all the things we need to just look at, and which in fact, nowadays coating technical file every ship has got now. That is also one of the IMO's directive. So coating design and structural redundancy. Okay, watertight, weathertight integrity. I need not explain much on this. As seafarers, all of us, we are aware of this. Watertight integrity. In case if there is a breach in any one of the watertight in a watertight compartment, what is happening? The flooding in that particular compartment. So then that leads to loss of reserve buoyancy to a certain extent. So in intact conditions, when in intact stability conditions, how much is the reserve buoyancy? Reserve buoyancy is 100. But whenever you have a breach, or whenever the vessel some grounding or collision, so there is a loss of reserve buoyancy. Yes, but it needs to be well within limits. That is why in SOLAS convention we talk about floodable length and permeability issues and all that. So watertight, weathertight integrity is very important. So that needs to be looked at. And human element consideration, yes, nowadays in IMO you will find a lot of, because the people, after all, who run the ship, are seafarers. So they need to be looked after, human element, so that the fatigue, a lot of importance is given. How to cut out this fatigue. It is addressed your working hours, rest hours. It is not only in your Maritime Labour Convention, it is in line with your STCW also. The same thing is addressed under IMO. So design transparency, whatever ship design needs to be transparent so that anybody can be looking at. So now these are all part of your functional requirement of IMO and this 5-tier system. So tier 1 goal set by IMO responsible for this, and functional requirement again IMO is responsible. And tier 3, verification and acceptance criteria. Yeah, this is again the responsibility of IMO. IMO will have various subcommittees, audit committees to just verify. And tier 4 is basically IAX, International Association of Classification Societies, common structural regulations for oil tankers and bulk carriers. Here the focus is only for this type of ships. So that is, as you can see, IAX takes the responsibility of fixing up the guidelines for how to construct a ship, the naval architectural strength calculation, what type of steel needs to be used, what should be the plate thickness, and these are all the things looked at. Okay, then the basic thing, industry, procedure, and quality system. So this is how your goal-based system moves on. Okay, Now, from goal-based standards of IMO, let's move on to the Polar Code, and I request you to look at the third point here. Polar Code includes mandatory measures covering safety part, as you can see, Part 1A, Part 2A, and recommendatory provisions, Part 1B and Part 2B. Now, you might have noticed in IMO, all codes, whether it is ISPS code or whether it is any code, including your STCW code, you will always notice the code has got two parts, Part A and Part B. Now, what is Part A? Part A is standards. That standards means you have to comply with. It is mandatory. That is why you see this mandatory. Now, what is Part B? Part B is guidelines. How will you comply with Part A? Guidelines are given in Part B. So in Polar Code also it is the same thing, because basically a Polar Code they have brought in IMO because now polar navigation is possible. Again, going back to our global warming issue, because of global warming in polar areas, the ice has melted. So now the ships can navigate through, but of course it has its own issues, because the idea why ship owners would like to navigate through polar navigation, basically it reduces the distance. So when the distance is reduced, the goods are transported much faster, and the reduction in fuel and all those things. But in Polar Code, as you can see, it addresses all these issues: polar water, operational manual, ship structure, subdivision. So you can just have a look. Any polar navigation ships should have all those things. And look at the last point: manning and training. That means people who work in polar ships. Our polar ships are basically, earlier we used to call it ice class ships. So polar ships manning and training. In fact, IMO has come out under STCW. There is a modular course has come out. It is called Polar Code, Polar Ship. Now this one, this is what does the Polar Code mean for the ship safety? So here, just to make it little bigger for you, so let me just show you. Yes, equipment size. So I hope you are able to read this. Are you able to read this, or should I make it a little bigger? Hello? Can you read this? Windows on bridge.
Yes, sir. Yes, sir.
Okay, windows on bridge, lifeboats. So here what does it say? Means to clear melted ice, freezing rain, snow, mist, spray and condensation. So the windows on bridge needs to cover all those points. Lifeboats, of course, clothing, because there it's going to be very cold for people who go to the polar region. And of course, ice removal becomes a requirement. You see, special equipment for ice removal, such as electrical and pneumatic devices, special tools such as axes or wooden clubs. It's all shown here. Of course, fire safety, the type of extinguishing equipment, even portable extinguishing equipment, if it is going to be a normal extinguisher like a foam extinguisher, it shouldn't get frozen inside, because the temperature outside may be very, very low. So that's about, and of course, if you see the design and construction, one thing I would highlight here, now look at the ship categories. Under Polar Code, ships are categorized into A, B and C. There are three categories. A means what? Medium first year ice. That means it's going to be a very thick ice. The vessel, will it be able to break the ice? To look at. Then B is what? Thin first year ice. And what is C? C is open water or ice condition less severe than A and B. Now, Polar Code categorizes the ship like this. So, whichever ship, this gradation will be given. Of course, intact stability, and of course, materials of construction needs to look at, because any steel, when it is exposed to a very low temperature, always you have a issue of brittle fracture problem. So, accordingly, the materials are to be looked at. And if you look at here, operation point of view, navigation, receive information about ice conditions, and of course certificates. It needs to have a polar ship certificate on board. That's a mandatory certificate. I would say statutory certificate given by the flag state, and also polar water operational manual. And here you can see the training. That means anybody going on the ship, masters, chief mates or officers in charge, they need to undergo a polar course, and then they need to prepare themselves. Now, this is with reference to safety. And likewise, I want to show you this, how the Polar Code protects the environment. Now, here, this is all about your MARPOL guidelines. So, here, oil structure, the vessel has to have a double hull. I will just explain it to you, even though you are not able to read. The polar ships must have a double hull requirement, like an oil tanker. But heavy fuel oil not to be used. You need to look at diesel oil or MGO. And of course, the lubricants need to be eco-friendly. Of course, here invasive species we are looking at ballast water. Of course, sewage and of course garbage. The garbage has nothing should be thrown out except the food waste. That again you have conditions. And of course, sewages. So these are all your main issues with reference to SOLAS and MARPO. Okay. Now, from Polar Code, gentlemen of IMO, we will move on to this. And if you see here, Annex 4, IMO has come out and declared Baltic Sea as a special area. And as you can see here, the focus is more on passenger ships because passenger ships have more number of, number of people on board. So you see the last line, all passenger ship visiting the special area. And also according, different dates are given. Existing passenger ship from 1st June 2021. So Baltic Sea, you need to have the proper sewage treatment plant and all that. Now this is about Annex 4 guidelines from MARPOL. And of course, this Ballast Water Management Convention, I think it is nothing new. All of you are well aware, and many of you in your last ship, you had it. And of course, it's effectively, as you can see, 8th September 2017, as you can see here, entered into force 12 months after ratification. So here it is 30-35%, 30-35. Whereas 8th September 2016, the condition was met. Then if you take 12 months from that particular date, that means 8th September 2017, yeah, you can say Ballast Water Convention got ratified. So what we need to do, as you can see here, any ship above 400 gross tonnage, it applies. So we need to, what are the records that you need to maintain? Every vessel, as you can see, the second point, approved ballast water management plan. So apart from that, you need to have maintain a ballast water record book, like your oil record book, and manage ballast water on every voyage by performing ballast water exchange or treating it in a treatment plant. And of course, survey will be done, and eventually every vessel needs to have ballast water management certificate. Now this becomes one of the required statutory certificates for all the ships now. So if you see the different standards you must have seen in the convention, you see D1, D2, D3, D4, D5. So in D1, see for example, existing ships or very old ships, even now, what does it say? 95% of your ballast water needs to be exchanged. Because the basic concept here is what the ballast water from one zone not to be transferred. Like for example, when a vessel is discharging, the vessel is taking ballast water. So when the vessel goes for loading in some other region after 10, 12, 15 days, then what will happen? The ballast water from the other zone has been taken and thrown out or deballasted in some other region. So the they say it leads to cholera, and they are talking about so many microorganisms by name, different types of microorganisms they talk about. So one of the method for earlier what we were doing, or many ships, very old ships will be doing, is D1 standards. That means 95% of your ballast water needs to be exchanged in the open ocean. As you can see, the distance is given and the depth of sea is also given, because we believe in the middle of the ocean, the chances of the microorganisms present and harmful microorganisms present will be very less. But if you look at D2 standards, now that is what is going to come now. It has already come. There we talk about performance standard. Now this performance standard, how are you going to achieve? Because unless otherwise you have a treatment plant. Now the treatment plant approval standards, that is your D3 standard. It is given there. And the last what you see here, G8 and G9 standards, basically the guidelines from the convention to the flag states, how you are going to approve the plants. Because your treatment plants, your ballast water management plants, you have either physical treatment like filters and your UV radiation, things like that. Apart from that, there are treatment plants which use active substances. That means what? That means you are going to use chemicals. So if you use chemicals, overdosing of chemicals, yes, the bacteria will get, microorganisms will get killed. But then when you do deballasting, what is going to happen? So the local water, chemicalized ballast water will be deballasted there. So that is going to cause local disturbance in the local ecosystem. So the G8 and G9 standards, as you can see, it is more than the ship, it is to the flag states. on what basis they should give approval to the treatment plant. So that is how it goes. And D4 standards is prototype. That means any ship owner, if he wants to join a program and if he wants to put his ship for any ballast water treatment, different designs and all that, he can use his ship for that. Then D5 standard is review. If you see D2 standards, now this is what this all of you are very familiar. Even though I've just taken it from IMO and I have put it here. So this is how that means when you have a treatment plant, the treatment plant, whatever water that is being deballasted should have something like this, less than 10 viable organisms per cubic meter, and per cubic meter greater than or equal to 50 micrometers, or less than 10 viable microorganisms in per milliliter that are less than 50. And this you are aware of this. This is just the D2 standards. And as of now, the treatment plant, this gives you just a idea how most of the ships you have it like this. It's nothing for me to much explain here. As you can see, while ballasting, this is what you are going to do. While deballasting, this is how you will do. And the blue lines, what you see is the active line, like your ballast pump takes the water and of course takes it through the filter, and your power supply unit, it is taking it through that where hypochlorite dosing is done. So then it enters the ballast tank for the voyage, where with this hypochlorite dosing, most of the microorganisms must have been killed. But then when you deballast, again, if you see the active blue line, from the ballast tank through the pump, when it is being deballasted overboard, you take it through a neutralization unit here. Say this neutralization unit, I think all of you have seen it on board. Sodium thiosulfate is injected. What to neutralize? Residual chlorine, because over chlorination is not conducive. So this is basically the ballast water convention, which has already come from the last 3 years. Now let us look at this. Now this IGF code, this has come January 2017, and many ship owners are looking at it just to change over. So this IGF code, what does it say? This code is basically International Code of Safety of Ships using gas or low flash point fuel. This is where the focus is initially for LNG ships. And as you can see in the last point, you can see for IGF code compliant vessels, people who are going to sail on the ship must undergo a course. As you can see, STCW, mandatory minimum requirement for training and qualification of masters, officers, rating. Because your LNG bunkering is very different from your fuel oil or diesel oil bunkering. So if you just look at this, how the reason why ship owners are going in for LNG bunkering, because
Sekhar,
LNG bunkering,
moderator
yes,
here. It's time for polling. I just inform it. Dear participant, please free to share your feedback by polling. The polling will occur in your screen.
Okay, it's only okay. You informed them. Let them keep polling. I'll keep talking.
Yes, sir.
Okay.
And one of the questions were raised by a candidate, Mr. Mahendra Kumar Tiwari.
Yeah, I will take the question little later. I want to complete this, then I will take. Okay.
Okay, sir. Thank you.
Okay. Now look at this. I want you to look at this graph. Now, what is happening? If you see the LNG here, this okay. Now here, if you see what is happening, this is your LNG. I'm talking about the cost, whereas this is your 180 centistokes or 380 centistokes of your fuel oil, and then this is your FGO. You see the cost price. Now the ship owners are looking at the difference in cost. That means the operating cost is going to be eventually operating cost will be less. Of course, initial investment will be you need to have a dual fuel diesel engine. So that you need to keep that in mind. And apart from that, by using LNG, your CO2 emission comes down. You are very comfortable with your compliance of your EEDA, and okay. Now I want you to look at one ship where your IGF Code Compliance ship. So, as you can see here, IGF compliant design is a LNG fueled commercial ship. It's a container ship, as you can see. So, gas existing physical spaces, it is shown there. LNG fuel. That means what you are going to do, your bunker tank, where is it going to be? Is it going to be in the engine room, or it's going to be, because I mean, look at a ship like this, a container ship. Container ship is having a bunker tank somewhere in midship, somewhere here. Huh? You can just see, this is your, you see a container ship. It's a 14,000 TEU container ship. And where is your bunker tank is here. This is a bunker tank. Just above the bunker tank here, you have a LNG bunkering station. And once from, see, the tanks are like this, and you are going to have deep well pump, right? The pumps are going to be here. Okay, now the pump will bring up the liquefied natural gas in the liquid form here. Now this is the fuel gas supply system. This is where the pressure is boosted, and then from there you will have a vaporizer, because your LNG from the liquid form, you need to convert it to the vapor form, and eventually where is your engine? These are the dual fuel engines. Like you see here, what is shown here is ME engine, ME engine, gas injection, and this is your dual fuel diesel engine generators. That means from here to here, you bring it to the, of course, engine room. Engine room is supposed to be safe zone. You need to have all the safety procedures. All that you will have. So this is how a container ship. Now, suppose if it is going to be a VLCC. Now, see, VLCC, where do they locate the pictures? What I have shown, I have taken it from Daewoo Shipyard. The ships, they have constructed all these ships, and these ships are already at service. Like you take a VLCC, where is the bunker tank? Bunker tank is on the deck, like this. Whereas this ship is a VLOC, very large ore carrier. Now here for this ore carrier, the bunker tank is something like this. So, and if this container ship, and where is your bunker tank? This is your bunker tank, and this is the pump. You can call it fuel oil transfer pump, what you have, something similar to that. So the blue line, what you see is your LNG going all the way. And of course, this you have in the fuel gas supply system on the deck. You have a pump which gets boosted. You see high pressure pump. Now from the pump, it comes all the way. And then you see number 3. Number 3 is what? High pressure vaporizer. Now from the vaporizer, it goes all the way to the engine. Because as you are aware, when you are injecting it in the engine, you need to do it only in the vapor form. So here, in this case, it is being injected at 300 bar pressure. Now this is a MEGI engine, ME engine with gas injection. And the equivalent to that is what? We have RT-flex engine. Okay. Now before that, you see, now in this engine, LNG bunkering again, you have main engine, you have your auxiliary engines, and this is the line supply where the LNG vapor, or you cannot call it LNG, we can call it CNG now, compressed natural gas, is being injected to all these engines. So these engines are why we call it dual fuel engine. This is the bunkering scene. So this is a container or a tanker or a bulk carrier, whatever it is, and this is your LNG bunkering ship. But when you are doing bunkering, there is going to be a lot of issues. The safety requirements are there. And the construction of the bunker tank itself is going to be exactly like the cargo tank of a LNG ship. Very often, they use membrane tanks where the inner tank material happens to be invar. Invar is what? Nickel steel. Nickel steel is about 36% nickel and the balance is iron. That's how it is going to be. So now this is just a concept of, how the IGF code compliance ships is going to be in future. In future, we are going to have more and more ships of this. One thing is compliance with the CO2 emission reduction, so that optimization of your EEDI taking place, and also the operating cost with reference to the price in the fuel price difference between your MDO or fuel oil and LNG makes a difference. Now, what sort of engines they have? Now, suppose if you take a diesel engine here, this is a dual fuel engine. Briefly, I'll just tell you. Now, this is your RT-flex engine, dual fuel, DF RT-flex engine. Now, where the gas is injected here, see the green color here. Now, these is the gas injection points. So, but at what pressure gas is injected? As you can see, now the piston has come down and your scavenge ports are open and scavenging is taking place. That means the pressure in the cylinder is going to be so low. By the time piston moves up and covers the scavenge ports, the pressure here is so low. At a pressure of, at what pressure, as you can see, low pressure gas injection around less than 10 bar, your scavenge, I mean your CNG is injected at this point, somewhere in your cylinder lube oil fill point, you can say mid stroke injection is taking place. Then at the end of the compression stroke, at the end of the compression here, the compressed. But then one thing is here we should know, it is not a self ignition engine like a diesel engine, because here because the auto ignition temperature of LNG or methane is going to be much higher than the compression temperature. So you have to inject a certain some fuel, either it can be fuel oil or diesel oil. But this is the concept of your RT flex. Whereas if you move on to your MEGI, in the MEGI engine, they are not doing this mid-stroke injection. They are doing it at the end of the compression stroke, right on top here. They are doing it, but then they are doing it at a higher pressure. Now see the difference. RT flex is doing at 10 bar, whereas your ME is doing at about say 300 bar. But in the previous slide, as you can see here, directly it complies with Tier 3. Remember last class we talked about for this slow speed engine, it is about 3.4 grams per kilowatt hour. So it is without any after treatment. When the engine runs on gas, it is compliant with Tier 3, whereas here it is only Tier 2. That means you need to have SCR or AGR. Okay, now that's about this. Now apart from that, this in my last class Marpol Annex 6, I have already covered this, because now all areas, there is not going to be any more SICA area or NECA area. It is going to be only ECA area. That means all areas are both for SOx as well as NOx. And again, this one on the IBC code in IMO, they are going to make some amendments they have brought out. And for passenger ship, they are talking about your stability calculation with the computer. That is the requirement that is going to come. These are all the minor issues which your IMO is now bringing in. And here, one thing you see, electronic record book. That means, can we have an oil record book electronic? Yes, you can. Can you have a cargo record book in a chemical tanker electronic? Yes, you can. So that is what, allowing the use of electronic record book as an alternative to hard copy record book. Now, this is what they are looking at with the word record keeping requirement. This is from 1st October 2020, this is coming into force. So the electronic recording, whatever we have, now this is much easier, but of course, manipulation will not be possible here at all, So it needs to be approved by the administration. Okay, now this is one. Of course, there are amendments on enhanced survey program. You see, this is basically bulk carriers, oil tankers and chemical tankers. And they are talking about ship construction file requirements and all that. They need to be there because this is enhanced. Now here, if you look at this IMSBC code, yes, they have brought out very important point here is what? Transportable moisture limit. Of course, why I have written here Emerald Star, all of you know, end of 2017, I remember the month is October, this ship Emerald Star went down, killing almost, 10 people in water, So only 16 people survived, and, the reason for Emerald Star, sinking is mainly they talk about liquefaction. Liquefaction is what? They had nickel ore cargo with moisture content very high. So that's why if you see here, test to determine the transportable moisture limit. Now this has become, unless the master or chief officer put a foot down and then check whether the moisture limit is safe to the ship's sailing, then only they should do. Otherwise, I understand. I have gone through the Emerald Star report. The main reason for ship sinking, they put it on to the moisture content of the nickel ore cargo. Of course, this carriage ban, yes, you are aware now, because since we have moved on to 0.5%, compliant fuel, if you have 0.5, then you cannot have 3.5 unless you have a scrubber. Now, that's what, this slide is all about. Now, this is very important. Now, see here, autonomous ships. I'll spend about 5 minutes here. Now, in IMO, this is one of the latest, in the last 2 years, you can say 2008 beginning, they have started in Maritime Safety Committee of IMO. They are talking about maritime autonomous surface ships. That is how they name it, MAS. What they are looking at is, now why not we have ships like this? That means nobody on board. This is fully autonomous concept. Okay, semi-autonomous, 50% autonomous, 75% autonomous is all okay. But then eventually the bottom line, they are moving towards this type of autonomous ships where they don't need anybody, master to chief engineer, nobody is required. This is the concept, how long it's going to take, because the MSC, they have formed a committee in IMO under Maritime Safety Committee, a subcommittee, which is looking at the autonomous surface ship concept. So this is basically a scoping exercise they have already started. Safe, secure, and environmental friendly it should be. So they are planning to see. Suppose if you say SOLAS, for example, safety of life at sea. So suppose if it is 100% autonomous, when there is nobody on board, there is no question of life, saving life. It's only saving the ship or, of course, commercially saving the cargo. So your IMO related instruments, whatever conventional documents we have, all these things required to get reviewed, and then accordingly, this is what may be introduced in IMO instruments. So MSC, Maritime Safety Committee, recognized that IMO should take a proactive and leading role. So the rapid technological development, because as of now, what in IMO, how they feel, one is artificial intelligence, second thing is machine learning, and the third thing is data management. Now, these are the three very important parameters making in every industry, whether it is an automobile industry, like, having cars without drivers, or in metros without drivers. So likewise, why not we do it in the shipping industry? That is the basic concept here.